this example 6. So what we're going to do is we're going to solve this system of equations using matrices and the inverse matrix, right? So first thing we want to do is take the system that we were given and break it into a matrix equation, where we take the coefficients of the variables in the equation and set up a 2 by 2 matrix. So we're going to have 5, 2, 1, 1 now, and then we're going to take our variable matrix, which we call V, and set it up here, equals the constant matrix right here. Okay, so we have a 2 by 2 times a 2 by 1 equals a 2 by 1. We identify the coefficient matrix as C, variable matrix is V, and constant matrix is A, which is the top line right here. Now, if we, in a standard linear equation, you would divide both sides by C, but there's no division with the matrices here. So what we're going to do is we're going to multiply both sides by the inverse of C, because we know that from an earlier slide that the inverse of C here times C is going to give us that identity matrix, which is similar to 1 in the number system. So the inverse of C times C is the identity matrix. The identity matrix times V is V itself right here. So then on the right side of the equation, in this middle line here, we multiply the inverse of C to A, okay? And it must be in this order, inverse of C first times A, and then that'll allow us to solve for the variable matrix, right? So the first thing we need to do after we set up our matrix equation here is to find the find the inverse of matrix C. So to do that, we have to find the determinant of C down here, and then it's 1 divided by that, and that becomes a scalar, which is multiplied to the modified version of C, right? So to do this, remember, we switch 5 and 1 here, down here, and then we change the signs of 1 and 2 in this matrix, all right? So let's find the determinant first of the original C matrix, right? So that's the multiplication 5 times 1, which is right here, and then minus 2 times 1, which is right here, so that's a 3. So now this section right here, 1 over the determinant of C, is going to be 1/3, right? So now we're dealing with 1/3 times the inverse of, 1/3 times the matrix 1, -2, -1, 5 times the variable matrix, the constant matrix A here, right? And all of this here is going to equal our variable matrix XY, basically. So I personally think it's easier to do the multiplication of the red and the blue matrix first, and then multiply the scalar in, right? It's easier to do the multiplication I just suggested than to multiply the 1/3 scalar to the red matrix and then multiply it to the blue. So this is a 2 by 2, this is a 2 by 1. So our product matrix, right, the inner dimensions match, so the product matrix is going to be a 2 by 1 here, right? So we're going to set that up. So here's my 1/3. And then I'm going to have a 2 by 1 matrix. So to do this, it's going to be first row, first column here. Whoops. First row, first column, right? So it's 1 times 11, that's 11, plus -2 times 4, so that's going to be plus a -8 or minus 8 here. That's going to be the first element. And then we're going to multiply this row, to this column one more time, right? So -1 times 11 is -11. 5 times 4 is 20, so we're going to add 20 to that, okay? And again, this is all equal to my variable matrix here. So we're really dealing with 1/3 here times 3 and 9. Now we're going to multiply that scalar in, so 1/3 times 3 leaves us with 1, 1/3 times 9 leaves us with 3 here. And then now we can associate our variables with values, right? So we basically have x equals 3, x equals 1, y equals 3. And then since we were originally solving a system of equations, our solution goes in an ordered pair here, 1, 3, now just solved a system of equations in 2 variable with a matrix equation using the inverse.